Okay, in the second part of this lesson, we're going to start combining what all we've learned about transformations and see how they can be applied to the real world. So have you ever wondered how computer animation is created? I know a lot of you like to play games on your gaming systems, like maybe, what is it called? Fortnite or Call of Duty. I don't know what is popular now. My kids are so old I don't even keep up anymore, but basic computer animation can be accomplished with the geometric transformations that we've been learning in the coordinate plane. So we're going to look at, not on Call of Duty or Fortnite level for sure, but we're going to look at an animation here. Certainly not going to be incredibly entertaining, but we're going to watch this dog skate. So, like I said, not quite up to the level of your gaming systems yet, but this is just a basic motion that we can use transformations to model. So, think about how we could use transformations to model the dog moving along that path. So, putting it on a coordinate system allows us to actually put some numbers into that transformation. So first of all, what transformation? Anytime you see this question, what transformation? We've only learned 3 transformations so far, and that is rotation, reflection, and translation. So when it asks what transformation, which one of those is occurring to get the dog from here down here? Well, obviously that's just a slide down the path. So we're using a translation. Now, anytime you tell that you're using a translation, remember you need to be more specific about the motion. How many units are you going to the right? How many units are we going down? We're going to be using a translation vector to show how that dog can move from here to here. Now, there's several different ways that we could show this motion, but one possible way is what they have noted here on the coordinate plane. So notice this line right here is denoting the path of the dog, and they have strategically placed the beginning point as the origin on the coordinate plane, the point 0, 0. Where we're ending up is at the point 8, -4. So again, there's more than one way to get from 0 to 0 to 8, -4, but one possible way is to go 2 units to the right and 1 unit down. Now, how many times would we have to go to the right 2 and down 1 before we would end up at our final destination of 8, -4? We would have to repeat that 4 times. So, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1. So, repeating it 4 times would get us to our final destination. So, on number 7 in your notes it says, what is one translation vector that would move the dog along its path? And remember, to write a translation vector, you need to use angle brackets. The first number is your left or right movement, and we're going to the right 2, so we're going to put a 2 here. And the second number is your up and down movement, and we're going down 1, so remember that means that's going to be a -1. Now it said, how would this vector be applied to move the dog from point A to point B? Well, we would have to apply that same vector 4 times in order to get it all the way from A to B. So we would have to go right 2, down 1, 4 times to get it from the beginning point to the ending point. Now the next animation is a little more complicated, but again, we're not quite up to the level of your games that you're used to playing. Here we have 2 dogs that we want to have move towards each other. So again, it's going to be helpful to put these dogs on a coordinate plane in order to describe the transformations that we need to do in order to get one from the other. So it tells us that the first thing that we need to notice is that this dog's nose is lined up with this vertical line that goes through x of -10. So we know that that equation of that vertical line is x equals -10. This one is lined up so its nose is at x equals +10. So if we were starting with this dog, the very first thing we would have to do is to get it facing the opposite direction over here. So what transformation would get it to do that? Well, you're having to flip the dog, so obviously that's going to be a reflection. So it tells us on number 2 to reflect dog A. Now, anytime you say a reflection, you need to tell across what line you're reflecting. And so we are equidistant from what line? This line right here, which we know that is called the y-axis. So we're going to reflect dog A across the y-axis. That would be the first reflection. Now that would get the dog over here. That would not get them moving yet. So this dog, we need to move which direction? Well, we need it to come this way to the right. This dog, we need it to go this direction, so it needs to go to the left. So for this dog, the translation vector that we would use would be going to the right, and one thing that they suggest is go 2 units at a time. Now we wouldn't have to go 2 units at a time. We could go 1 unit at a time or 5 units at a time. But if we go 2 units at a time to the right, we're going to put a positive 2 in the X spot. We're not traveling up or down, so that means a 0 will go in the Y spot. Let me get this in the center of the screen, sorry. If we want this dog to travel at the same rate toward the line, then that translation vector, since we're going to the left, we're going to go the same number of units at a time, so -2 will make it go 2 units at a time. And again, it's not going up or down, so that would be a 0 in the Y spot. So those 2 transformations together would get the animation that we needed. It would flip the dog and face it this way. This dog would go 2 units at a time to the right, and this one 2 units to the left, and eventually they would meet at the Y axis. Now, how many times would we have to repeat this translation in order for them to meet up at the y-axis? Well, since there's 10 units to the y-axis and we're going 2 units at a time on both of these, that would need to be repeated. How many of the translations? You would need to repeat that 5 times in order for them to meet up at the y-axis. So number 9 in your notes is 5 times. Our final animation, again, sorry guys, we're not up to your gaming standards yet, is a glider. So if we watch this glider, we can see that it's placed on the coordinate plane with this point set on the origin. And maybe that's on our next one. Let's see. Nope, let's go back. Sorry, I thought maybe they placed it on the coordinate plane, but they did not. So we're just going to imagine it on the coordinate plane with this point in the center that it's rotating around. Remember, that's called the center of rotation, that fixed point. Imagine that being at the origin. So you'd have a y-axis here and an x-axis here. Now, what transformation is occurring here? And remember, anytime we talk about what transformation, we're saying, is it a rotation, reflection, or translation? Well, this glider is turning, so we know that that is a rotation. So on number 10, what transformation would make the glider follow the exact path shown? It's a rotation. Anytime you describe a rotation, you need to tell how many degrees, what direction, and around what point. So let's talk about those 3 things in addition to rotation. So if we started here, look, remember every quarter turn is 90 degrees. So how many quarter turns did we make? 1, 2, 3. So we did a rotation 270 degrees from the starting point to our ending point here. Now, which direction did we go? Remember, this is called clockwise. If we went this way, it would be counterclockwise. So we went clockwise, even though the natural progression is counterclockwise. This rotation was clockwise. And around what fixed point? Remember, we said that was the origin. So around the origin, or you can write it as an ordered pair, 0, 0, either one. Okay, so I know it's the end of your notes, but I do want to talk to you about a couple more things. So if we look at our ending slide, it says if you want the image of point P, and I'm just going to write this up here at the top of your notes, you have some blank spots. So you're given point P, and it's 3, -2. And you want to perform the translation vector of in angle brackets, -5, 7, where would P prime end up? That's the question. So remember, this is the movement on the x-coordinate. My x was 3, but I want to go to the left 5. So all I have to do is take 3 and subtract 5, and that will tell me where the x-coordinate of my new point P prime is. So 3 minus 5 is -2. This is the movement on the y. It's positive, so we're going up. We were at -2. We went up 7, so we can do -2 plus 7. That is going to end up at a +5. So this is my image point, starting with this point P and performing that translation vector. So remember, what is a vector? So it is a quantity that has two things: magnitude, which is length, and direction. That is really important. A couple of things I want to go over on your homework paper so you'll be clear on what the expectations are there. On number 1, your directions tell to describe in words what transformations, and I want to really draw your attention to the fact that that is plural. It means there's more than one transformation that's occurring. You're going to describe it in words. So if you say a reflection has occurred, what line are you reflecting over? If you're saying it's a rotation, how many degrees are you rotating? Around what point? What direction are you going? If you're saying it's a translation, how many units are you translating, and in what direction or directions are you going? You might be going left and up or right and down. Might be a combination. So be very specific in describing in words what transformations, plural, will get you from the dog that's in quadrant 1, this one, to the dog in quadrant 3, this one. Number 2, you're going to write an ordered pair rule. To take that you just described in words from quadrant 1 to quadrant 3, you're now going to write an ordered pair rule. Remember, anytime you see ordered pair rule, you're going to begin by the generic point x, y, and then an arrow. And then you're going to say, what are you doing to the x, comma, what are you doing to the y? Number 3, now the dog needs to move into his doghouse. So it says what single, remember that means just one, transformation will move the dog so that his nose, which is starting here, will end up here. And you're going to describe it in words, and it's only one. So don't say it's a rotation and then a translation. That's not a single. Single means only one. So only a rotation or only a reflection or only a translation. Only one. And describing it in words. So be specific. Remember, if you say reflection, what line are you reflecting over? If you say rotation, how many degrees, what direction, what point are you going around? If it's a translation, what direction or directions are you going and how many units? All right, on the back, you are writing an ordered pair rule to get the dog from this dog standing up. You're wanting it to roll on its back, so you're wanting it to end up as this dog right here. Ordered pair rule, remember you're going to start with the generic point x, y in parentheses, have an arrow showing it's mapping to new point, and what are you doing to that point? And it's always helpful just to concentrate on one point. So if you'll concentrate on the nose, you're getting from this point to this point. Write an ordered pair that would get you there. Number 5, you're writing the coordinates of the terminal point. That's your ending point in a vector. So you have a starting point and an ending point in a vector. So it tells you your starting point is 2, 1. It tells you what translation vector you're using, and it wants to know what are the coordinates here of your ending point. Number 6, you want to write vector notation. Remember, that's in angle brackets. What would get you from this point to this point? So you want your left to right movement, comma, up and down movement. Same thing for number 7, except you're given a graph of those. So you're going to have to look at the coordinates and the motion and write that as a vector notation. Vector notation. Left to right movement, comma, up and down movement. Don't forget, we have a quiz tomorrow. Study. Ooh.